Hi everyone, my name is Çise from Industrial Engineering Department. Today we are going to present you model building and evaluation.
So firstly, we will be giving a brief introduction of our dataset to remind you of what we're working on, and we will briefly talk about the manipulations we did in the previous presentations. And after that, we're going to talk about the new things we've done after some recommendations of our instructors, such as new feature constructions. And lastly, we will be talking about how we selected our hyperparameters and then our models. And then we'll finish with our results. Next slide, please. So our dataset is a synthetic dataset called Predictive Maintenance Dataset by Stefan Matka. And our aim is to predict if the machine is going to fail, and if the machine fails, which type of failure it's going to give. We'll be using supervised learning method, and our classification will be multi-class classification.
Hi, I'm Seyit. In the beginning, we had an imbalanced data set. To balance data set, we used a smooth method for oversampling. Before oversampling, we had 10,000 samples. After oversampling, we obtained 19,000 point 200 instances. We added a failure type column with using our initial failure type columns. The initial failure type columns removed. The new failure type column became our new target, and we encode the failure types. Next, please. After we create dataset, we split our dataset by 80 and 82, 20%, 80% for training and 20% for testing. Approximately, we obtained 9,600 for training dataset. Next, please. We tried some models without hyperparameter tuning. The models were CNN, 3, Arda Boost, Naive Bayes, and Random Forest. However, except Random Forest, these models didn't give enough results. Therefore, we decided to continue with Random Forest model. Random Forest were fast.
May I interrupt, Seyit?
Yes, hocam.
I wonder, here there are several metrics for classification. The
Yes,
classification
hocam.
accuracy, F1, precision recall, under area curve. So which one is important for your project?
I think F1 score is important for us because and also CA classification accuracy is important because we have we will multi-class classification, and these metrics is important, I think.
And
may I add something, teacher?
Yes, please.
AUC is important too. On our last slide, you have said us that you have a video on your channel that is about how to evaluate classifiers with imbalanced datasets. You say that there, even if F1 score is 99% and AUC is 0.5, it is like worthless.
Yes. So now your problem is multi-class classification, right? And
yes,
in the previous slide, you have shown us that with smooth method, you try to oversample the minority class, which is the problems occurred or not, right? So here
yes,
also you see that there is the evaluation results for target, and here you have a combo box. You see that here, I mean, just a moment. If you notice, we have this one. Why we will use, have you ever click this combo box, select something else?
No, I didn't remember hocam.
No.
I don't remember even if I did.
Orhun, Arda?
I did, and I see, but now I don't remember. That was
Okay.
last
Zeynep?
slide.
Zeynep?
No, hocam, true. I mean, I
Çise?
haven't checked it.
No hocam.
Nobody wonders what it is, huh?
I
We
checked
did
last slide,
probably.
but I don't remember.
Yeah.
Okay, so actually, you have several. Remember that when I talk binary classification, I talk about that. What's your positive class? What's your negative class? Remember in the class?
Yes hocam.
Yes, hocam.
Because the results for the binary classification reported for the binary class, positive class, right? For if you are talking about classification accuracy, it's for the positive class. The precision recall also calculated for the positive class. F1 also for positive class. If you are taking care of, if it's dog or cat, if your positive class is dog, your result always related with the dog. How many dogs correctly classified, for example. Recall precision F1. But now yours is multi-class classification, right? And which
Yes,
one
hocam.
you are most interested in? For example, for the classification accuracy. So in your problem, since it is imbalanced data set, right? So you have the majority class and minority classes. Am I right? One majority class, which does not have any problem, right? The
Yes,
other
hocam.
are the some machine problems, right? ABC type.
Yes,
So
hocam.
these are minor
Yes.
classes, right? But these
Yes,
are
hocam.
results for average for these 4 or 5 classes. We have, I think, 5 classes, right?
5.
Right?
Five.
Five,
Yes,
hocam.
5.
Averages for 5 classes, but
Actually, 6.
actually you are not interested in that averages. You are actually what? Interested in?
Hocam, we're actually interested in finding whether the minority class has been classified correctly. Even if we didn't realize this part, we actually examined confusion matrices to be able to see how the classifications work.
Then in model selection and in hyperparameter tuning, you have to be careful about this. Okay, so if you open this in your real orange tree, you would see the other classes and you can continue like that. Or I don't know, in multi-class classification, did you put every error in one class? Is there any class like that?
No.
I think, hocam, do you mean the failure type? Because the
Yes.
failure type has the
Just failure,
example 0 for no
one or
failure
zero.
and 1, 2, 3, 4, 5 for the other ones.
Yes, but is there any class for failure 1 or 0? Any class like that? Can you show me
Just for if it fails
Hocam,
or not.
there was, but we we took that one out.
Can
There
you show
was
me the previous slide? The data.
I think one before.
The data. No, not this one. Here. The failure type is 0, 1, 2, 3, 4, 5. These are the classes, right?
Yes,
Yes,
hocam.
hocam.
Yes.
So 5 classes. Is there any 6 class like that the failure occurs or not? 0, 1.
No hocam.
No.
No.
We excluded that.
If it was like that, then you can
Hocam,
select
this one is like no failure occurring, and these are the
I see,
failure
but
types
it is
over
just
here.
0 means that
But
no occurs.
no failure,
There is
yeah.
no 1.
Yes.
Do you understand? Okay, but you got my point, right? So you cannot
Yes.
select your model or hyperparameter according to average of these classes metrics, because you pay more attention to the problem case,
Minority classes. Yeah.
right? Minority classes.
Right.
Okay.
We actually
So
checked
in
that
your
with ROC
final
codes.
presentation and final report, please take care about these problem and do the tests, experiments accordingly. I report it.
Okay, hocam, we'll keep this part in mind.
Okay, please continue.
Random forests were fast to train and easy to prediction, so we choose it. Next, please.
Okay, here you will see the modifications before oversampling. Here is the confusion matrix before oversampling. In before oversampling, model performs well in tests, results and 0.97 as F1 score. However, as you can see in the confusion matrix, in the first column, there are too many false negatives. So we have to convert it into a true version. So after oversampling, the model performs worse than before oversampling in test result as 0.9958. But in the diagonal, as you can see, it shows true positives. This confusion matrix becomes more accurate than the before oversampling confusion matrix. So it is more accurate.
Çise,
Yes, hocam.
have you ever checked here
Which one?
this combo box?
No, hocam.
Anybody else in the team?
I have
Hocam,
checked
I
it.
think we don't see the
think
combo box.
I think you can show the percentages there.
Yes. Here, these are the nominal numbers, number of instances, but you can see the percentages, which is much more better because here 37. Do you think that 37 is a big mistake compared to 15K?
No.
We don't know. It's not easy to calculate. But if you
Yeah.
select here the percentages, you would see, for example, 1.3% is misclassified. Do you understand my point? So in that kind of presentation, don't use the number of instances, but use the percent of instances. Do you understand my
Okay,
point?
hocam.
It
Yeah.
will
Yeah,
be
okay.
very easy for us to follow you, and it's gonna be easy for you to express what you found. In your
Okay.
final presentation and your report, please fix it.
Okay, hocam. When we compare the matrices here, as I mentioned before, the diagonal shows the true positives, and it is clearly seen that the after oversampling matrix is better than the before oversampling and more accurate, of course.
Çise, may I add something to the previous one? Like we were saying that the first one has like the false negative, so like it predicts that the machine, when the machine has failed, it predicts that it hasn't failed before we oversampled. And after we oversampled, it was having correct predictions as well as those similarly false negatives and as well as false positives. But even despite these, we believe that it's way better since it's able to classify things correctly. Okay, next one, please. And
for me, actually, it's not easy to see that left or right one is better than the other.
Hocam, but diagonal shows
Hocam,
the true positives.
Over here,
Yeah.
these ones are like when the actual one is 1, let's say it predicts 1. When the actual is 2, it predicts 2. But over here, it doesn't predict any of them correctly. But over here, it predicts out of 1.5K, 1.4 of them correctly, misclassifies 101 of them, let's say. So these ones we're able to see that the correct classifications occur over the diagonal.
Okay.
Okay, and so as per your suggestion from our previous presentation, since we had less features, we decided that we should be constructing new features, and we examined what we have. in terms of our errors. And one of the features we added was regarding the temperature difference between the air temperature, the outside air temperature, and the process temperature, which is inside the machine. And we looked at some definitions such as heat dissipation, which occurs when the heat of a hotter object is transferred to the colder objects and the surroundings. And the temperature difference is what determines this rate of heat transfer. So we took this one as one of our features. And as well as power, for example, we can have the machine fail due to like power related issues. So we decided to put another feature as power by multiplying the torque and the rotational speed, which is similar to the angular velocity when we found. And when we looked at the correlations widget, we saw that the highest correlation was indeed between these two things we used, between rotational speed and torque and air temperature and process temperature. And lastly, we added the feature called strain, which is a kind of deformation on the tool itself, and it will increase with high torque when the machine spins faster, or like when there's more force on the tool piece, and with higher tool wear. So these are the features that we've added. Next slide, please. And then by using our base model, which was random forest as we selected, as Seyit mentioned, and we compared the test results before having added these features and after having added these features, and we saw that the accuracy of the base model increased after the addition of these features. Let's see, for example, before the feature construction, our results were kind of similar between classification accuracy and F1 score being 0.96, and it's increased to 0.97, or actually almost 98.
Okay, so I kindly remind you again that please select the percentage here, so we can see that at least for the classification accuracy for each class. Okay.
Yes, okay. I'm understood.
So please do this. And for the precision and recall and F1, you can select, for example, I don't know, 1, 2, 3, 4, or 5 classes, I mean, so that we can understand that if F1 score is good for the minority classes or not. Okay.
Yes, I'm understood.
Thank you.
We'll be doing it like that next time. Okay. Thank
you. I'm Eray Bedir from Information Systems Engineering. After adding new features for hyperparameter tuning, we split the data to 80 to 20% and split that 80% to another 80 to 20% for validation for hyperparameter tuning. My friend Arda will mention this later. Next slide, please.
Excuse me, how many samples we have in the original, in the pre-processed data set in the end?
I don't
19.2K,
and then it became 19.2K.
Okay. For the validation, mostly we use 9 to 10 if you have more data. Okay. So I think it's good for you. You can try 80 to 20 for the test and train split. But for the hyperparameter selection or the tuning, 90 to 10 is better. Okay, because we would like to check with less data. Okay.
Okay, we will do that. Next slide, please. Here you can see different model results for hyperparameter tuning. For example, on the right side top, you can see KNN results. After increasing the K from 1 to 5, our F1 score drops, but our AUC score got higher slightly. The difference is not much, but when we checked on which one is more important, AUC, we took AUC into account since it's
I would like to ask you a question. If you know the AUC, area under curve, so it is 1.0, right? But if you notice that, for example, KN3 and 1, right? For example, let's say the F1 scores and the precision and recall, they are all good for KNN1, right?
Right.
Why it is like that?
I don't really, I can't really explain that.
For train data, right? You notice that?
Because already know the train data.
Yes. Because it memorizes. If it is the KNN applied to the train data, you are asking one point which exists in the train data. So it is, right?
I checked the right side for that, but I didn't see. It's
I
you
am
said
talking about
I understand now. I couldn't get it.
right?
Yes.
So it is obvious now because you are asking one sample from the existing train data.
Yeah.
Right? Because
right. I know it.
You train the model with train data and you test the data with train data, right? So it knows the data inside that. If it's KNN1, there is nothing to average. Just repeat the value. So it is 100.
Yeah, I knew it, but I just looked for tests in that, but I couldn't get it.
You missed a good point.
I think he misunderstood you, Hocam, at first. But yes, we realized that the KNN1 memorized after
it was an easy one.
Test.
Yeah.
Okay, let's continue.
AUC is more important, we decided, than F1, so we chose the KNN5. There was no difference between the 3, 100 and 1000, so we chose 100 for performance. And it was the same for random forest 20 and 50. We chose 20 for performance. Next slide, please. This was about your video. I saw it in your video when you told us to watch it, how to evaluate classifiers with imbalanced dataset. ROC curve, basically, it tells how much the model is capable of distinguishing between classes. The line in the middle at degree, it's like random guessing, 50 to 50.5% is the worst it can be. And here you can see our RF random forest values are nearly perfect. Like on a ROC curve, how much it is closer to the left and the upside defines how good is it because the under the area under the line is AUC, and if it's closer to 1, it means it's better for distinguishing between classes. So
Eray, may I ask a question?
Yeah.
What is that?
Where I can see. It checks for target 1.
Why you choose the target 1?
We choose the target 1 because the difference between the models in the target 1 was greater. You can see it better. Like the lines were much farther away from each other.
Çise, would you choose target 1, label 1?
Hocam, no, I wouldn't choose 1.
Why not?
Because of the confusion matrix.
What is the class 1 in your problem?
I guess RNF, or I don't know.
Orhun? Arda?
Not sure, but it can be
Class 1 is what?
TWF.
What?
It can be TWF. It can be two-year failure, I guess. But I'm not sure.
Eray?
I couldn't remember.
Eray, what is the class 1?
I can't remember either.
In the beginning, we use names of failure types. Then we change them
We got
to
so
numbers.
used to numbers, so
we are not sure now.
If you go a little bit back to your presentation, the third slide, here, this is the class, right? class one.
Yes.
Yeah.
Yes.
Right?
Yes, hocam.
So what is
But
that
we don't know
class?
the identification of it right now. As
I think this is toolware
it could
failure.
be toolware
hocam.
failure, and we have to check back right now. But actually, we examined all of them in the ROC curve. But as Eray was saying, the difference was
Now,
seen
let
more.
me ask you,
That's why we showed it here.
will you report these ROC or will you report this? Which one you would like to report?
The one for one, because we're interested in how well it classifies the minority
Right?
class.
Because these are the minority
Yeah.
classes and the
Yes.
success is important for that classes, right? Because
Yes.
since
Right.
it's the majority class, randomly you select the majority class all the time. All the machine learning models normally tend to opt to select majority class.
Majority.
So if you go to back again the last slide you are showing, we were discussing.
Yes, hocam, we're checking
Here,
for the
Here, if you please pay attention, all this, okay? If you are showing me 0, it will be very big problem because I don't care about
Yeah.
this, right? Okay,
We checked each target. Random forest was better and similar in all of them. And in one, we can really see the difference between different models. So we chose to show one, either two or three. Next slide, please.
Hi, my name is Arda from Computer Engineering. After hyperparameter tuning completes, we start our model selection part. For this part, you can remember our dataset was split in 8:20 ratio for training and testing. For model selection, the 80% portion was used in training. The models with hyperparameters that we choose on hyperparameter tuning part, and 20% part is used in testing our model. This 20% part has never been seen before model to make a healthier test and get healthier results for real-life problems. Next slide, please. Here, these are our model selection results. We compared performance of models to choose best performance. As you can see in figures, KNN with number of neighbors 5 has the lowest accuracy and other things like F1 and AUC. After that, 3 model with under 3 depths, and last and our favorite model, random forest with 23s, has the best results overall, as you can see in figures. Next slide, please. This is rock curves of these 3 models. For very good models, rock curve should be between 0.9 and 1, as I mentioned before. In here, you can see random forest has best curve, and RF20 is random forest, means random forest. This is for target 1, but it's in error for all other targets. So we use random forest. Next slide, please. This is the end of our slides. Do you have any questions? Thanks for listening.
Arda,
Hocam,
can
you're
you go
muted.
2 slides back? In the model, one more, please. Here, can you explain the data set split here? I cannot follow here.
8%
This
part.
is what? First split. This is the 20% data, is that?
Yes.
Yes.
And this is the
Upper part
80%, right?
Yes.
And then this is the test data, am I right? Goes to the model selection. This one is what?
Hocam, it's the train data. We
data,
just wanted to see them
80%.
separately.
Yeah.
It must be coming from here. Is it the same data? What is that one?
Yeah. Teacher,
Data
first
table,
split
is it?
1 is 100% of our data. Then data sample to data, I mean 8% first train
So
data
it is
table.
written test
Our
data as well. What is that one? Actually, this is the test data, train data. Am I right? Can you explain me?
Yeah.
Arda.
That 8% our train data.
No, can you use the pen and can you show me?
Sorry, I didn't understand. Can you repeat it?
Can you use the pen and show me?
Where's the pen?
Okay, it's almost above your microphone. Annotate comes up.
On the left side, here.
Right below.
Oh,
I don't find pen. Actually, I won't say
Over
it, then I
there.
guess.
yeah, it's a green one.
Okay.
Click the pen
That
icon.
8%.
Where is it?
We,
Okay.
in Eray's slide, this 8% was there.
Okay.
And also in here, it's there. Strain data. This is 20% never seen data before. It's never seen before. This is test data. We use this train data to test this 20% test data. This one.
For the
Test.
model selection. Okay.
This one is our train data.
Okay. So where these others goes to?
Hocam, it's for the.
These are
It was for something
in
else, I think.
Eray's slides. That's actually same thing, but it's really big in orange. So we divide it like that.
Okay,
Hocam,
Arda.
our orange is really complicated.
Okay, can you go
We
Yeah,
divide
please
it.
go to
Isolated.
one of them
three
goes to model
slides
selection.
back, 3 slides back? Yes, here. No, more back.
No, it's, isn't it? The thing that we,
No,
this
you
was
need to
the
go
second
back.
one.
Is that the one?
Yes, hocam, this is the
Yes.
one for hyperparameter.
No,
This
okay.
80%
Say
here
it.
train and
Say it.
other 80% test
Okay,
train
Arda. Say
are
it
same.
then. Okay, Seyit Cem.
Yes, hocam. Yes,
Can you
hocam.
explain me why we are using this data?
Which one, hocam?
This one.
For split model selection. Hocam, first one, we
Say it.
we split data and remaining data we downside. After
I am
that,
I am
sorry for
asking you this kind. What is happening here? What's
okay.
happening
We take 80% of the data, and we make here hyper parameter tuning for. Again, we split it to 80% for train and 20% for test,
Test
and
or
we send
validation?
it
Validation.
Test or validation?
validation hocam.
Okay. All right. Thank you for the presentation. I already provide some feedback for you. Okay. And please provide some figures. All right. Some figures like that, right? Some, I don't know, line charts with saying that this is KNN, I don't know, with 5, KNN with 3, KNN 9. And these are maybe, I don't know, the recall, precision, F1 score, something like that. So I can see in one chart. Okay. You already screenshot and you provide it. It's okay. But when you put something, make it looks like much more professional for your final presentation and for your final report. All right?
All right.
Okay, hocam.
Any questions?
Hocam, I would also like to point out something. Like in the classes, you've told us to use PCA for the feature selections and stuff. We tried it, but it kind of messed up our results. We got
Why?
really low accuracy. I don't know. But
But
we
you
did
have
it,
to
and then
edit
our
as a new feature. As a new
hocam,
feature.
in the slides I was saying it was coming from the like data sampler, and then for example, the chain was getting transformed by PCA, and I mean we did it like that, and it was being like 0.6 accuracy.
For the PCA, okay. At the end of the PCA, you just get to the data table. Okay. And using this data table, and using this data set, the original data set, I mean, you have to put together the features and then use it. Most probably, it will increase your the final performance metric.
Oh, okay then hocam, I think we used it in a wrong way then.
Yes.
Yeah.
Do you
Because we got
everyone
something
understand what
strange.
I'm suggesting?
Yes.
Yes, hocam.
Very understood.
As a extra feature for the existing feature. If you have these number of features plus principal component 1, principal component 2, principal component 3, 3 more features. Now you have, for example, 12 plus 3, you will have 15 features to do your model flowchart. Okay? It will
Okay.
help you. Any other question?
No.
Okay. Thank you for the presentation. Please improve your presentation and the report. All right. Thank you.